Hello, this is GED Live at PALS with teacher Alex. The subject is GED Science and the topic is Earth systems. Let's have a quick overview. We will talk about the structure of Earth, tectonic plates, Earth's atmosphere and the greenhouse gases, the ozone layer and its depletion, and air pollutants and their effects. We'll as well talk about weathering and erosion. There are three main layers that make up the Earth's interior. Each layer has its own materials, properties, and conditions. The crust is the outermost layer. It's the thin outer layer of rock that includes both the dry land and the ocean floor that covers Earth's surface. The crust beneath the ocean is referred to as oceanic crust and consists mostly of dense, dark, finely textured rock called basalt. Continental crust forms the continents. It consists mainly of granite, a lighter, less dense rock with larger crystals than those found in basalt. This makes sense since substances with higher density sink below substances with lower density. So the lowest density rock forms the land masses, whereas the higher dense rocks form the oceanic crust. The mantle is the boundary of hot rock beneath the crust. It is composed mainly of silicate rocks that contain lots of iron, nickel, and magnesium. The uppermost part of the mantle and the crust are similar. Together they form the rigid layer called the lithosphere. Below the lithosphere, temperature and pressure increase with depth. This added heat and pressure results in less rigid rock that is somewhat bendable and plastic-like. The asthenosphere is a soft layer of the mantle where material can flow freely. The core is at the center of Earth. It's made of metals like iron and nickel, and it's responsible for the Earth's magnetic field. It consists of two parts, the outer core, which is molten and liquid, and the inner core, which is solid and dense. Together, the inner and outer cores are just slightly smaller than the Moon. The magnetic field of Earth is produced due to the rotation and movement of the core. So here one more time we see the structure of the different layers. We have the crust, underneath the crust the mantle with the lithosphere and the asthenosphere, both part of the mantle, and the inner and outer core. Tectonic plates. The oceanic crust and continental crust come together in sections to make up 8 primary tectonic plates and many other smaller plates. All of the tectonic plates have names that usually refer to their location and proximity to certain land masses, oceans, or regions of the globe. These plates slowly move or float on the mantle by means of convection currents. Convection currents are hot currents of molten rock that cause the plates above them to move 1 or 2 centimeters each year. You can watch the class or the presentation on heat transfer to find out more about convection currents. The 8 major plates are the African plate, the Antarctic plate, the Eurasian plate, the North American and South American plate, Pacific, Indian, and Australian plate. The motion of the tectonic plates provides an explanation for the formation of oceanic basins, mountains, and continental shelves. Continental shelves are gently sloping, shallow sections of the ocean floor that extend outwards from the edge of a continent, which we can see up here. The water depth is usually to a maximum of 200 meters before the continental slope, where the depth drops to several thousand meters down to the abyssal plain. Ocean basins are vast geologic regions below the sea level that cover nearly 75% of Earth's surface. Ocean basins contain features such as deep-sea trenches and mountain-like ocean ridges. Tectonic plates are the key to the formation of these features. There are three types of plate boundaries. The transform boundaries, where crust is neither produced nor destroyed, as the plates slide horizontally past each other. We can see this example at the bottom here. We have divergent boundaries, where new crust is generated as the plates pull away from each other, which we can see here. And we have convergent boundaries, where crust is destroyed as one plate dives under another. This collision can bring together two sections of oceanic crust, two sections of continental crust, or one of each. The relative densities of the two plates determines which plate comes out on top. The less dense plate will stay on top, the more dense plate will submerge below the other. Here we have the three examples. Ocean, ocean, subduction. Two ocean plates. Continent and ocean plate. The ocean plate will subduct beneath the continent plate. In these two scenarios, volcanoes can form, since the subducted plate will start to melt and the less dense rock of it will start to rise. In a continent-to-continent collision, we have often an upthrust and the formation of mountains, which we will talk about now. Mountains are made when one plate slides on top of another plate. Fault mountains are created when the collision of two plates squeezes the two plates together. The layers of rock are slowly pushed towards each other and rises upwards in folds. This formation of mountains often happens when continent-to-continent collisions happen, or as well continent-ocean collisions. Trenches are created when one plate is forced down into the mantle beneath a second plate. In areas where trenches are created, volcanoes can occur. A volcano is a weak spot in the crust. When heat deep beneath Earth's surface melts the plate material that was forced down, molten rock called magma is sent to the surface. Magma that reaches Earth's surface and is on the surface is called lava. The movement of two tectonic plates sliding past each other can create earthquakes. Earthquakes are found by the shifting and breaking of the surface of rocks. The break in the crust where earthquakes can occur is called a fault. Faults usually occur along plate boundaries. The atmosphere. Scientists estimate that Earth formed about 4.6 billion years ago. After a certain passage of time, it is thought that gases from Earth's core were expelled from volcanoes. The envelope of gases that now surrounds the planet is called the Earth's atmosphere. These gases are most dense at the sea level and become increasingly thinner the higher in the atmosphere we get. The atmosphere exists as a series of layers, each having its own characteristics. The following table lists the characteristic features of each layer, as well as its location relative to sea level. We can see the different layers here. Closest to sea level, we have the toposphere, 0 to 10 kilometers. It sustains life, it's where all the weather occurs, and we have increased wind speeds with height. A fall in pressure with increasing height, and temperature decreases with increasing height as well. After that comes the stratosphere, 10 to 30 kilometers. Here the temperatures increase with height, although this cannot be felt due to the decreasing density of the air. This is where we find the ozone layer. If you want to know more about the ozone layer, there is another presentation on that topic as well. have the mesosphere, 30 to 50 kilometer, rapid temperature fall caused by the lack of water vapor. We have the thermosphere. Here we have another rapid increase in temperature with height due to steady influx of the solar energy. But again, this can't be really felt due to very few particles left in these heights. The ionosphere is an electrified region that contains large concentrations of ions and free electrons, and the exosphere, the last layer which merges the Earth's atmosphere and outer space. Atmospheric gases, the air around us, part of the tropospheric layer, is a mixture of gases. It contains 78% nitrogen, 20% oxygen, and trace amounts of several other gases, including hydrogen and carbon dioxide. Gases in Earth's atmosphere hold in heat from the sun and help to support life in the troposphere. The process by which gases in the atmosphere trap solar energy is called the greenhouse effect. Greenhouse gases include water vapor, carbon dioxide, and methane. This is how it works. Most radiation is absorbed by the Earth's surface and warms it. Some solar radiation is reflected by the Earth's atmosphere as well. Some of the infrared radiation passes through the atmosphere once it is reflected from the Earth. Some of it is absorbed and re-emitted in all directions by greenhouse gas molecules. The effect of this is to warm the Earth's surface and the lower atmosphere. This causes a recycling of heat energy. Without our greenhouse gas layer, the average surface temperature on Earth would be very low, in the negatives, around -10, -15 degrees Celsius. So the greenhouse gases are actually really important to create an environment that can sustain life. However, the effects of gases on Earth, human activities can add greenhouse gases to the atmosphere. This may contribute to steadily increasing temperatures over the last century. Global warming is a gradual increase in the temperature of Earth's atmosphere that affects climate change. Due to the increased greenhouse gases introduced by human activity, more heat is re-emitted back to Earth's surface, which causes global warming. Another global change in the atmosphere involves the ozone layer. Ozone, O3, is a molecule made up of 3 oxygen atoms. Ozone works as a protective blanket in the atmosphere, filtering harmful UV rays from the sun before they reach Earth. Scientists have identified areas where the ozone layer has become increasingly thin. They believe that a group of chlorine compounds known as the chlorofluorocarbons, or CFCs, are the main culprit. CFCs were widely used in refrigerators, air conditioners, and spray cans until the late 1980s. Like most chemical compounds released into the air, the CFCs do not break down easily or quickly. They last for decades, rising into the stratosphere where ultraviolet radiation breaks down the chlorofluorocarbons and breaks them down and releases chlorine from them. The chlorine atoms then break down ozone into oxygen atoms, destroying the protective ozone layer. We can see it here as an example. We have the chlorofluorocarbons rising into the atmosphere where they are broken down by UV light. The chlorine then reacts with ozone to form oxygen. Ozone is depleted and is not able to block harmful UV rays anymore. Some sources of pollution that impact the integrity of the ozone layer, the quality of air you breathe, and your overall health are shown here. Other pollutants are oxides of sulfur, oxides of nitrogen, carbon monoxides. from burning fossil fuels. Here are a list of some of the harmful air pollutants. Particles in generally, which come from internal combustion engines and cars, industry, factories, burning wood, cigarette smoke. They can cause lung cancer, heart disease, lung disease, or asthma attacks. Nitrogen dioxide comes from burning from combustion engines as well, and other combustion processes. The exposure to high levels of this gas may lead to lung damage and respiratory disease, and it's also linked to asthma and respiratory problems, as well as acid rain. Carbon monoxide comes from, again, combustion engines from cars and burning coal and oil and wood and other industrial processes. When inhaled, carbon monoxide enters the bloodstream and disrupts the supply of oxygen. It's highly toxic since it binds to the hemoglobin in our red blood cells permanently, which means these red blood cells will not be able to transport oxygen anymore. Lead is largely derived from the combustion of lead additives in fuels, and it retards learning in children and the development of their nervous system. Hydrocarbons are chemical compounds composed of hydrogen and carbon atoms. Most fuel combustion processes result in the release of hydrocarbons to the environment. The largest fuel sources are natural gas and petrol. They are also components of the smoke from wood fires. Exposure can cause headaches and nausea, while some compounds may cause cancer. Some may also damage plants, and methane, which is a hydrocarbon, is another very potent greenhouse gas. Weathering is the process where rock is dissolved, worn away, or broken down into smaller and smaller pieces. There are mechanical, chemical, and organic weathering processes. Organic weathering happens when plants break up rocks with their growing roots, or plant acids help dissolve rock. Mechanical weathering physically breaks up rock. One example is called frost action or frost shattering, when water gets into cracks and joints in bedrock. When the water freezes, it expands, and the cracks are opened a little bit wider. This repeats and repeats and repeats until the rock is broken into smaller pieces. Chemical weathering decomposes or decays rocks and minerals. An example of chemical weathering is water dissolving limestone. Erosion it happens when rocks and sediments that were previously weathered are picked up and moved to another place by water, ice, wind, or gravity. When ice melts or wind and water slow down, they can't carry as much sediment, and the sediment is dropped or deposited in landforms. Let's have a look at some questions. Which of the following could form if two tectonic plates collide and layers of rock are slowly pushed towards each other? Earthquake, ocean basin, fault mountains, or volcanic trench? You can pause the video. The correct answer will come now. Fault mountains is the correct answer here. Let's label the layers of Earth. You can try it yourself. The correct answer is coming now. You can pause the video. The outermost layer is the crust. Then comes the mantle with the lithosphere and the asthenosphere. Then comes the outer core, which is liquid, and the inner solid core. What chemicals are the major cause of the depletion of ozone? You can pause the video to answer the question. The correct answer is coming now. Chlorine compounds, specifically the hydrofluorocarbons. Connect the correct term to each layer of the atmosphere. One term will not be used. You can try this yourself again. I will tell you the answers now. You can pause the video. The lowest layer from 0 to 10 kilometers height is the troposphere. We are skipping the stratosphere and directly go to the mesosphere. Then comes the ionosphere and the outermost the exosphere. This was GED Live at PALS with teacher Alex. The subject was GED Science, the topic Earth Systems.